day everyone, my name is Treasure. I'm here at Festo today to present installing of a PLC. Now, what is a PLC? So PLC stands for Programmable Logic Controller. Programmable logic controllers are devices which we use in production lines. So they wire to sensors, switches, actuators, and motors, many other different components in a production line. And these PLCs are then programmed using a software. On the computer, you write a code and then you load it into the PLC so that you can operate the machine without need of a computer. Now, PLCs were first invented in 1968. Ever since then, they've been becoming more powerful, cheaper, and different variations. For an example, this is one PLC that you find in production lines. This is a CPX Festo PLC, and it's assemblable in different configurations. So this is the actual CPU of the PLC. And we've got also here the IOs. So when I say IOs, I'm talking about inputs and outputs. Now this will be the base and the CPU, and this is the IOs here. So this is an IO module. This can be digital, it can be analog. You can also opt for other field bus communication platforms, which I will go into depth in the future. So yes, you plug this and then you write a code for the PLC. You obviously have to do the hardware configuration so that the CPU knows what is connected. Another type of a PLC is this. This is made specifically for education. So this is the PLC here. The PLC can be used for various of applications, but the entire rack, we call it EduTrainer. This is for education. Now, this has 14 inputs. It has 8 outputs, so 1 byte of outputs. It also has IO link interface. This is now talking about field bus. Imagine that you have an application where you have more than 8 outputs. In that case, you then have to use a remote IO device, which is this one I have here. This is it's an IO-Link device with 8 inputs and 8 outputs. So this way I can maximize the IOs of the PLC. It has an Ethernet port for communication. This is when I load the program. Also for what we call Profinet communication. Also, this can be done for that. Here, and then this is the USB where you might want to load a program into USB if you don't want to use Ethernet. This is CAN bus. So when you talk about CAN bus, this is another field bus protocol where you could be using the PLC to control a electric drive or any other industrial device that is capable of CAN open. Now, Festo isn't the only manufacturers of PLCs. Siemens is one of the very commonly known manufacturer of PLCs. This is ET200S. So much like the CPX, ET200S is flexible in terms of that you can plug different IO modules. So in this case, I have about 4 digital inputs, one module would have 2 digital inputs, so I have 4 of them. And then I have 8 digital input module, and then I also have 8 digital output module, 2 of them. So this way I can then plug this to a machine such as the MacLab, if you're familiar, or the MPS modular production system. Then I write the code to load it into this, and voila. And this is the connection here. So this is syslink connection. So this has 8 inputs, 8 outputs. I also have 8 inputs and 8 outputs, which can go to different systems. This can go to a control panel. This can go to the machine itself. This is for emergency purposes. So I can wire in series. Here, I can wire an emergency stop, so that if I press the stop, such as over here, so this is an emergency here. Such an emergency will be wired to a connection here. So if if your system does not have emergency stop, then you would use this bridge. This is just so that there can be a connectivity between the 2 lines. Now, PLCs are usually not used by themselves. They're used in conjunction with HMIs, stands for Human Machine Interface, and also supervisory control and data acquisition. An example of an HMI is this here. This is a Festo CDPX. Now this is a LCD screen here, and it also has it's a touch panel, so I can touch the different parts of the screen. So as a mechatronics student or as a mechatronic technician, you would design the interface. And an example of such an interface is this over here. So this is another type of an HMI. This is a Siemens SIMATIC HMI, so this is a type of an interface which you would have on your HMI. But you may ask, why do we need this touch screens in the displays? So these can be used for, so if you can imagine, a control panel would consist of buttons and switches. Now you might want something more sophisticated than a button and a switch. You might want to display an analog value, something that is ranging like a voltmeter, for instance, or something that will show a value of a sensor, let's say a level sensor or a flow sensor, pressure sensor. So HMIs becomes very useful tool for that. And also for remote control. Imagine that you have 10 HMIs in your production line. You want to have a centralized control. That is where SCADA comes in. So you would have all these HMIs on the PLCs, and above you will have a SCADA, supervisory control and data acquisition, which will oversee everything. As I said, PLCs uses, there's softwares to program PLCs. You know, for the CPX and the CECC, we use codices. Codices version 3.5. So for the Siemens PLC, we use TIA Portal. Also HMIs, there's a software that you use to design the interface and also to program the HMI. So this HMI is actually 2-in-1. It can be used as a PLC as well. So for that, you would use codices. However, to design the interface of the HMI, you would use Designer Studio. It's a software. Codices is a software, as I said, to program a PLC. Where can you, as someone sitting at home, where can you get the software? So you can go to our website, festo.com/portal, support portal, and this is where you can download the software. Once you're on our support portal, there's a search there. You can type there, codices. And go to software. Here you will see the different versions of codices. So if you're going to be working remotely, not using a real PLC, then you can use any version, or you can use any service pack of this codices. But I would strongly recommend that you go for the latest, which is then Service Pack 3.5.7 Service Pack 2. So you go to File and Versions, and then you can download by clicking there. Because I have it installed already, I will just carry on from there. So once you've installed this software, this is what it will look like. So you can go to File and create new project there. Give your project a name. So I'll give it a default name. And so this is the thing here. So select a standard project there. So there's all the different options. Now, if you're going to use a real PLC, you would install the target supports. For instance, you could be using CECC. So the target support for CECC can also be found on the support portal. So you go to support portal, you type CECC, and then you will see all the different target supports, which you can then bring in and install into codices. And when you create a new project, you will have to select the PLC. For the purposes of this first lesson, we're going to be using PLC Sim, which is PLC simulation. We will not connect to a real PLC. However, we will still be able to write a code and simulate it and see how it actually works. So now there's also the different languages. There is the different languages in which one can program in. There's structured text. As you can see on my screen, there's sequential function chart, continuous function chart, instruction list, function block diagrams, ladder diagram, many of them. We are going to look at a couple of them. So I would like to first start with the sequential function chart. Okay, so this is what the new project would look like. So the project tree would start with the device, which is what we are having as a control Win version 3, and the application, the library manager. Now, I don't want to confuse you and start to talk too much details about the different things. I will explain them when we get to them. So what is most important at this point is the PLC PRG. This is the page in which you will write the code. Okay, now, what you must ask yourself is, okay, so now I have codices, I'm ready to write the code. What is important is for you to understand exactly what you're trying to achieve in the end of the day. So you need to have a concept on paper. You need to have your sequence, you need to have your logic in your head or either on paper. So that when you write your code, you know what to do. Because at this point in time, you will actually have a tough time trying to imagine what you're going to write. Now, for the purposes of this lesson today, we're going to write a code for 2 cylinders. So I have 2 cylinders, one extending, the first one extending, the second one extending, the first one retracting, and then the second one then retracting. Now we spoke about 2 cylinders, first one actuating and then the second one then actuating. I'm going to demonstrate here on this visualization. So we need to turn automatic on, and you can see the first cylinder extends, the second extends, the first then retract, and then the last retract. We need to write a code for this. And if you look at this interface here, I'm showing the 2 actuators with each having its own 5-2-way valve, single actuated, and also an what we call a control panel at the bottom with some buttons, start, stop, reset, and automatic manual. Now, typically what happens is automatic manual, it can be a button, it can be a switch, but in most cases it's a key, because you wouldn't want unauthorized operation of your equipment. So you would have a key that goes into the automatic manual, you turn it to automatic, and then you can then start the operation. Without the key, the machine shouldn't operate. So in this case, I'm using a switch, toggle switch that goes up, down. All right. This is what I mean. So first, what is important is that the actuators have to be in the initial position. When I say initial position, I mean default position. Default position of a double acting cylinder is retracted. Before you do anything to the cylinder, it should be in a retracted position. This is why we have reset at the top. Then automatic mode, which will require a key or can be a toggle switch, which is here. And then only then you can then start the system. And then after you have started the system, then production can then happen. Production, I mean the cylinders will then will extend and retract in the sequence that I've demonstrated earlier on. It is only when there's an error or only when I press the stop button that production should stop. And you can see that I have the stop here, and stop will then result in the sequence going back to reset. These are what we must keep in mind when we are going to write a PLC program. The second thing that I'd like to put out is this one. Now, 1M1 is the first actuator that we've seen in the visualization, and 2M1 is the second cylinder. Well, these are solenoid valves, but they control the cylinders. We have 1S1. 1S basically is to say 1 is the first actuator, S is a switch. So I have 1S1 on the first cylinder. Let me go to that visualization to show you what I'm talking about. So if you look at this cylinder here, it has a limit switch here. It also has a limit switch over there. These 2 limit switches are 1S1 and 1S2. While on the second cylinder, we have 2S1 and we have 2S2. So we rely on them to have a controllable sequence or to have a reliable sequence so that we don't have a second cylinder extending before the first cylinder is fully extended. We rely on the limit switches for that. Now we are clear. So in this diagram that I'm showing here, you can see that at first, which is here, at first all actuators are off. And you can see that when both actuators are off, two limit switches are on, and those are 2S1 and 1S1. Here they are. And so what then happens is that we press the start button at some point, or let us say production starts, and then the first cylinder extends, which is 1M1. And then you will see that after the first cylinder has fully extended, which is here, the second cylinder then extends. After this, you can see that when the second cylinder is fully extended, the first cylinder will then start to retract. Retract. While the second cylinder remains extended. Then what will then happen is that after this first cylinder is fully retracted, the second cylinder will then retract. This should have been 2M1. So we have 1M1 and 2M1. Perfect. Okay, this diagram will help you a lot, will help you a big deal when you are going to write a PLC program. Because what it does is, it helps us to have conditions, to set our conditions. If you look at these conditions, they differ. I have first set of conditions here, first set of conditions which is here. And you look at these conditions, they are all different. And this is what we need. We don't want conditions that are the same, because the moment that you have similar conditions for your code, then that's when you're going to have interlocking signals. Okay, let us look at an example of structured text. Structured text, basically, it's a coding in terms of texts. I hope we will have enough time so I can continue to show you the function block diagram. In structured text, you will see that we have case step off. Case step off is a command which we use so that we can divide our sequence in terms of steps. And you will see that the first step is step 0. Let us see what happens at step 0. S1, it says if S1, so S1 actually is a start button. S1, then step 10. So it means that if S1 becomes true, then case step off is going to jump to step 10. However, we also have another command line which says if S4, S4 is, if you look in the control panel here, S4 is reset. If reset, then let me press it so you can see. Press S4, press S1, there we are. So if S4, then 1M1 becomes false and 2M1 becomes false. This is if I reset the system so that both actuators becomes or retracts. We then have jumping to step number 10, and you can see in step number 10, this is where those 1S1s and 1S2s becomes important, because we're going to rely on them so that we can initiate the system. You can see that we have S3 as well. So S3 is actually automatic manual. This is the toggle switch. So we have if 1S1 and 2S1 and S3. If those are true altogether, we will have 1M1 extending or becoming true. And once that happens, we jump to step number 20. Step number 20, we then look at the different conditions, because now that the first cylinder has extended, you can see that we now have these commands here. We have, you can see that the first cylinder is extended here, and then the second cylinder is still retracted. We will rely on 1S2, which is the limit switch for the first cylinder that is extended, and 2S1 for the second cylinder when it's retracted. We will rely on those two conditions to go to the next, to actually extend the second cylinder, which you will see that 2M1 is true. We then go to step 30. Step 30, we look at 2S2. We look at that the second cylinder is now extended. After this, we will then retract the first cylinder, which we can do that by saying 1M1 equals false. Now we go to step 40. Step 40 relies on 1S1, because now that we have retracted the first cylinder, we will then look at the limit switch for that the cylinder is retracted. And we will then turn off the second cylinder so that it retracts. You will see that after end case, so we have case step off. At the end, we have end case. So this is to ensure that whatever steps we are putting should be between end case and case step off. And you will see after this, I have if S2. This is the stop. So that if I press stop while case step is in any other step, or 0, 1, 0, 10, 20, whichever step, so that it goes to resets to step 0. Let me demonstrate what I'm talking about. So I will start the system. You can see that the cylinders are extending in the sequence, and if I press stop, the system stops. You can see that it jumps to step 0 there. Let me start it again. So you can see that the steps are jumping 10, 20, 30, 40, 10, 20, 30, 40. Only when I press stop, you will see that it resets to step 0. This is important. So now we will add a POU, which is the programming page, so that we can add sequential function chart and start our coding there. Now, what you're going to have to do is to declare the different variables. You need to declare the different variables. I've spoken about S1, S2, S3. Those are the buttons. And then we've spoken about 1S1 and the 1S2, 2S1, 2S2. Those are the proximity switches. 1M1, 1M2, those are the different actuators. So I just need to bring that information in here. Okay. And what you need also to do is to look at this. This is task configuration. What is inside task configuration is what will be loaded into the PLC. So I need to remove ST, structured text. This is the previous program that I was demonstrating. And I need to bring in the new program, which is the sequential function chart, into task configuration. And I need to remove ST out of task configuration. Okay, so you will see that sequential function chart is a lot simpler than structured text if you're new to PLC programming. So the first thing you will see is initial. So initial actually is initial step, stands for initial step. What happens in the initial? At this point, we don't want anything happening there. However, we want reset to be the first button, to be the, if you look at this, we have reset in the beginning. So we need to code the reset. We need to put in here. We need to put in here S4. This is the reset button. So that if I press reset button, we can then jump to the next step, which is step 0. What happens in step 0? What happens in step 0 after you press the reset button, 1M1 and 2M1 have to be false. So we will add an action. So action can be R or S. So I'm going to use R because R stands for reset. So we are resetting 1M1. We're also going to reset 2M1. After resetting, what we need to do is we need to turn the key switch or the toggle switch to automatic mode. And by the way, when it's on automatic mode, the switch is 0. When it's on manual mode, the switch is 1. Right, so now this is how our program looks when it's finished. I'm going to explain it a little bit and then we're going to test it. So you will see at initially this is at boot when the PLC starts. Nothing happens there, there's no action. Then we have S4. GVL stands for global variables, so I've moved my text to global variables, which is this over here, GVL. Now, you will see that the first thing is S4. S4 is reset, so you need to reset the system. Then it jumps to step 0. Step 0, that's when we reset 1M1 and 2M1. Reset, you can see that it's noted by R. Letter R here and letter R there. So we are resetting both of them. We have S3, which is the automatic. So we put the system in automatic. We have S1, we then start the system. You will see those two conditions, 1S1 and 2S1. Together, they turn on, they set 1M2. Then once this is happening, we will see that the second limit switch on the first cylinder then turns on. We extend 2M1. The limit switches for extended, the limit switch for 1M1 and 1M2, they're both on for the extension. This is when we reset 1M1 so that the first cylinder retracts. Thereafter, we reset the second cylinder. So I'm going to quickly demonstrate what this works, how this works. Okay, you can see that, let me reset the reset warm so we can start from 0. You can see that at first we're at initial. Then it waits for S4. S4 is a reset. So I reset everything. Then it jumps to step 0. Step 0, it waits for S3. S3, we know that it's automatic, so I turn automatic on. And it waits for start, which is S1, to jump to step 2. So I press start, it jumps to step 2, and we can see the sequence happening. Okay, we've looked at PLC programming, we've looked at the different PLCs, we've looked at structured text, we've also looked at sequential function chart, we've also looked at visualization. So on the left of the screen, I have visualization. This is, you can see that it's here, visualization, visualization manager, and visualization. Here we are. Now, the different variables can be found in the toolbar of visualization. So in visualization toolbox, you can see that I can bring in visualization toolbox. There are the different controls, the basics, basic controls and common controls. So I can bring in a text and so on. So that's what can be done with codices. Thank you very much. See you next time.